I'm gonna go through a few examples on how to simplify logarithms, and mainly using these logarithms in logarithmic laws, so they're going to be here on the left the whole time to refer to them. We mainly use them to simplify and help us solve equations. So first let's just practice simplifying them. So for example, if I have log with a base 8, 6, log base 8 and 3, and I need to simplify them. So I have an addition here between the logs, and it means I can use this first rule. Keeping in mind that your base has to be the same in order to be able to use this rule. Similarly, for the second rule, your base has to be the same. So I have the same base here. It means that since I'm adding them, same base, I can multiply the two arguments. So base 8, and I could go 6 times 3, and that is 18. So that's a simplified version of this expression. And then something similar, but with a negative. So if I have log with a base 5 and argument 9, log base 5 and 3. Similarly, I have the same base. It's a subtraction. I have log. It means I can divide the powers. So 5, and then I'll go 9 divided by 3. And you can simplify it then, and that will just be 3. So this is log with the base 5 and then 3. So we've used the second rule here. Say we have something like log 7, base 7, 6, and then minus 1. So I want to simplify it, but I'm subtracting by a whole number, and this whole number is not a logarithmic function. But if I look here, I can actually use this rule where I can convert the 1 into a log function as I want. So I'll go log base 7, 6 minus. I'll change this 1 into any log you want. So this could be log base 3 and 3, log base 4 and 4, and so on. So you can convert it to whatever you want. But if I convert it to something, I want to be able to then use this log with the first one. It means I'd prefer to make the bases the same. So I'm going to make a log base 7, 7. This should be equal to 1. And then because I have the same base, I can now use the second rule. If I use a different base, then there's no point of me converting the 1 to log 7 because I'm still stuck. So using the same base here is going to help me use the second rule. So now I have log base 7 and then 6 divided by 7. Make sure you always go in the correct order, so 6 divided by 7. You can leave it as such, you don't need to simplify it any further. And so we have 2 log of base 10, 5 plus 2. This plus 2 is not inside. Just to note, if you have any, for example, log 10 plus 2, if it was part of this log, then they would have put brackets around. So just to be aware of this. So what we could do is use a couple of rules here. This is playing around with some of the rules. I'm going to use the third rule here, where the power is the coefficient. So I can go backwards and make the coefficient the power. So I have log base 10, 5 squared plus 2. I could also change this 2 to be another log form. You can either do it in your head, or I'm going to go through the long process. Similarly to what we did in the beginning, I will have, let's say this is a 2 times 1. So I will convert this 1 into something with the same base. Now since I have a base 10, I'll pick a base 10, so this is 2, and then the 1 will be log base 10 and then 10. Then I have, I'm going to use the same rule that I did here where I change the coefficient to the power. So I'm going to have log base 10 5 squared plus log base 10 10 squared. You could have done this in your head if you wanted to, because 10 squared is just 10 to the power of 2 would be 100. So you could, if you're comfortable with converting between exponentials. Otherwise, you could use this fact. These are tricks that seem very new right now, but as soon as you're introduced to them, you can use them continuously. So we have the same base, we're adding them, which means I can multiply the argument. So 5 squared times 10 squared, and that would just be 25 times 100. So I have log base 10, 2500. So that's for the first set of examples. If sometimes we expect you to use expressions to rewrite logs in terms of other expressions. So if I have x equals to log of 2 and y equals to log of 6. So I have my ways of representing log of 2, log of 6, and I'm picking these letters. And I want you to rewrite log of 12 in terms of x and y. So I need an expression, so something in algebra in terms of x and y. So the algebraic expression should only include x and y. So we have, so what you want to do is to have an x in there, a y in there. Well, you can see that 12 can be split into different composites. So I have log of 2 times 6. And since I have two things that are being multiplied, I can split them up into two logs. So now I have log of 2 plus log of 6, given that it's a multiplication inside, and I know log of 2 is x, and log of 6 is y. So there you go. Log of 12 is now equal to x plus y. So if I do something similar with log of 3, log of 3, there's nothing that could multiply where I could use these numbers, and I can't use this type of, I can't do 5 minus 2, for example. It won't work, but I could use a division here. So this could be a log of 6 divided by 2, and I know that division would give me a subtraction, so a log of 6 minus a log of 2, and I know log of 6 is y and log of 2 is x, so that's y minus x. And then for the last one, if I have log of 48, so a bit of manipulation here should give you a heads up. Given that you need to use 6 and 8 somehow, 6 and 2 somehow, I gave it away. It's 6 times 8. Again, be comfortable with the powers of 2. These are quite useful in any example you do in math. So this can be, just to use the first rule, we have log of 6 plus log of 8. Well, I still don't have anything with log of 2, but I know that 8 is basically 2 cubed. So log of 6 plus log of 2 cubed. And I need to use the third rule here, where the power in the log becomes a coefficient. So I have log of 6 plus 3 log of 2. Log of 6 is just my y, and log of 2 is x, but I have a coefficient of 3, so 3x here. And then for the last example, something similar, but we're kind of using logs inside of logs. So if I have x is log base 3 and the argument is p, y is log with a base of 3 and q, and z is a log of base 3 and then r. And if I want to write the expression, same question in terms of x, y, and z. So if I have log of 3 p q over r, for example. So you can tell that if I substitute a couple of these in there, it's going to be a lot of expressions to deal with. So let me use the rules to just simplify this a bit more. So I have log of pq minus log of r, and I know that pq is a plus, so log of p plus log of q minus log of r, and they're all to the base of 3. We have to write the base of 3, because if we don't, then it's a base of 10 by default. To continue with the example, we then can easily go back here and see, well, I know that log base 3 of p is just x, and log base of 3q is just y, and log of base 3r is just z. So we are just using the rules that they gave us. So always go back. There is a long route you can go to where you use these expressions, but try to be smart with how you use them, how you manipulate the equations. So just one last example on these. If I have the same rules, but now I need to simplify, log of base 3 p squared r over q cubed, and splitting them up as we've done before, of 3q, and then I use the third rule where I change the power to a coefficient. P, and then this was cubed, so I changed the 3 here. And again, I know that log of p is just x, so I have 2 of x, and log of r is just z, and log of 3q, base 3q, and is just y, so 3y. So a quick simplification here using the expressions that we have.